The point of the second video part here is to investigate ways to solve systems of equations. This is the same example that we did in the first video lesson, and now we're going to talk about how to solve it. Now I obviously know you can solve this one using, I'll call this traditional algebra. In this case, traditional algebra, we can see that A is 3 and then plug in the 3 and solve using elimination, so on and so forth. That's pretty easy to do here. But I'm going to use this example 1 to also talk about a process called row echelon. So it's row echelon form. The method is Gauss elimination. So that's new. That's a linear algebra type of process. Number 3, we're going to look at a matrix. Now there's matrix by hand and then there's matrix by calculator. Finally, number 4, one you should be familiar with is Cramer's rule. Cramer's rule deals with determinants. Assuming that you know traditional algebra, I'm going to go to row echelon form. What we're going to do here is look at the coefficients. Here the coefficients for A is 1, coefficient for B is 1, coefficient for C is 1, and that equals 4. Then we have 2, -1, 3, 13, and then we have -3, 0 for the B, 0 for the C, and -9. The ultimate goal in this is to have something that looks like this: 1, 0, 0 going down, 0, 1, 0, 0, 0, 1, and then you have new values here, and these new values will be your solutions to A, B, and C respectively. Now, to do this, actually, I'm going to make this be the first line. So I have -3, 0, 0, -9, and then I'm going to continue with 1, 1, 1, 4, and then finally 2, -1, 3, 13. The reason for that is when you have your zeros already, you don't want to translate them into any value other than 0. So in effort for me to get a 1, 0, 0 somewhere here, I need to put this line first. Now to get this -3 to be a 1, I divide by -3. And that leaves me with 1, 0, 0, dividing the -9 by -3 gives me a 3. And then I continue as follows. Okay, we're ready for the next step. The next step, once I have this 1 fixed, the next step is to get these values here beneath that 1 to become a 0. So what do I need to do here? In order to make this 0, I'm going to multiply this value in this row by -1 and add it to the second row. So I have the 1, 0, 0, 3. Now if I take this times -1 and add it to the second row, I get a 0. And I will continue that process. Multiply this by -1, add it to the second row, I have a 1. Take this by -1, add it to the second row, I still have a 1. Take this by -1, add it to the second row, and that turns out to be 1 also, because -3 plus a 4 is a positive 1. Okay, now I'm going to skip to here. So if I multiply the top row by -2 and add it to the bottom row, I'm going to get a 0, which is what I wanted. Then I'm going to get a -1, I'm going to get a 3, and then I'm going to take this number here by -2 and add it to the 13, and that's going to give me a 7. A 7. Good news is, on the second line, 0, 1, 1, 1, the second row that is, this value is already a 1, so I'm in good shape. And this value above it is already a 0, so I'm in good shape. So the manipulation that needs to occur is taking and getting this -1 here to become a 0. So how do I do that? Well, if I take the second row, multiply it by a 1, and add it to the third row, then I'm going to get a 0. 1 times a 1 is 1. Add it to the second row, I get that 0 that I need. And then the 1 plus a 3 is going to give me a 4. And then the 1 plus a 7 is going to give me an 8. So we're in real good shape here. So you see that we've got to make this 4 a 1. So let me rewrite what we have. 1, 0, 0, 3, 0, 1, 1, 1. Now I want to make this row such that I have a 1 in this position. So I'm going to divide every element by a 4. 0, 0, 1, and 2. So we're not done yet, because this is successfully a 1, but I need all other entries in that column to be a 0. So 0, 0, 1, with a 2. So what do I need to do to this row, and then adding it or subtracting it to the second so that I eliminate the 1? Hopefully you see it's multiply the third row by -1, add it to the second row. That'll give me a 0. 0 times a -1 gives me the plus the 1 gives me 1. 1 times a -1 added to this value is going to give me that 0. A -1 times the 2 will give me a -2. Add it to the 1, and that gives me a -1. No manipulation is needed for the first row because we already have a 0 in this entry here. And there we have it. We have the values A, B, and C. Now this one turns out to be C because I switched it in the beginning. This one is going to be the value of A, and this one here is going to be the value of B. So we have A is -1, B is 2, and C is equal to 3. The same result you get if you were to do your traditional algebra. We're going to discuss Cramer's rule next. In Cramer's rule, we do something similar as the row echelon form. 1, 1, 1, 4, 2, -1, 3, 13. These are the coefficients. -3, 0, 0, -9. Like this. So I'm going to solve for one of them, just so you get the point. Let's suppose we're solving for A. We set up a determinant. D here will stand for the denominator, not for determinant. The denominator, we will look at a determinant 1, 1, 1, 2, -1, 3, 1, 0, 0. Now why did I make that 1, 0, 0? Because it just makes sense here, just like in the other form, to divide everything by -3. Okay, so there we have it. So this will become our denominator. Now you have to remember how to do a 3 by 3 determinant. So we take this value here and in our mind cross these out. So this is going to equal 1 times a new determinant, negative 1, 3, 0, 0. Next, I have this value of a 1. And if you recall, it goes plus, minus, or as is opposite. And so from the blue, I cross out this way and down, which leaves me with a determinant of 2, 3, 1, and 0. And then finally, we look at this value here, and that's going to be, in this case, a plus 1, plus, minus, plus. And crossing out here and down, I have a 2, negative 1, 1, 0. And then to actually solve these determinants, 2 by 2, that's easy. It's bump times bump minus bump times bump. I like to say the bumps because it helps me remember. Bump, bump, bump times bump. So negative 1 times 0 is 0. Minus 3 times 0, which is 0. So we have a 1 and a 0. Again, that's negative 1 times 0 minus 3 times 0, which equals 0. Now let's take a look at the blue. So I have a negative. I got to figure out the determinant. 2 times 0 is 0 minus a 3 times 1. That's going to give us a negative 3. And then finally for green, I have a plus. 2 times 0 is 0 minus a negative 1, which becomes a positive 1. If I add those up, I get 4. Yep, I get a 4. So that's going to be the denominator. Now that's going to be true whether I'm solving for A, B, or C. The denominator is going to equal 4. So now let's take a look at the numerator. But it's the numerator for A because I'm solving for A, and I would do the similar process for B and C. So I'm trying to find the numerator for the A value. So what do? I'm going to come back to this original, and I'm solving for A. So A is associated with the first column here. So what I do is I replace the first column with the solution coefficients. These are the solution coefficients, and they replace the first column because I'm solving for A. And now I have a new 3 by 3 determinant. So I have 4 times negative 1, 3, 0, 0 determinant minus 1 times 13, 3, 3, 0. Now I'm fouling this up because this should be, no, I'm not. This is good. Finally, plus 1, 13, 3, 3. Oh, crud. Now I messed it up. This is 13. This is a negative 1. This is a 3. And this would again be 0. There we go. Okay, so now we have 4. We'll do our bump times bump. 0 minus 0 minus 1. 0 minus 9 is negative 9. Plus 1 times 0 minus a negative 3, which becomes positive 3. Add those together and you get a 12. Alright, so I'm going to sneak this in somewhere. So for the value of A, it's going to be the numerator for A over the denominator, which is going to be 12 over 4, which equals 3. And that would successfully solve for A. You would do a similar process for B and C, except you would over here replace the solution with B and then the solution with C, finding the 3 by 3 determinant there. We're now going to look at a matrix method. So if we had some matrix A, not to be confused with the value of A, but some matrix A times some matrix X is going to equal some matrix B. The solution to this would be matrix X is equal to the inverse of matrix A times matrix B. Okay, so what are all these? Matrix A is going to be our coefficients of the values 1, 1, 1, 2, -1, 3, and I'm going to again use the 1, 0, 0 instead of the 3, 0, 0. -9, 1, 0, 0, 3. So that's matrix A. Matrix X would be a matrix of the variables we would want solved. So A, B, and C. And then matrix B is a matrix of the solutions 4, 13, -9. So you see here, if we actually did matrix A times matrix X, hopefully you remember a little bit about matrix multiplication. This would be applied to this row and this row and this row, leading to 1A plus B plus C, and this would lead to 2A minus B plus 3C and 1A plus 0B plus 0C. And the result of that would be 4, 13, and negative, not -9, would it be? It would be -3. -3 here. Sorry about that. Yeah, this would be like A equals 3, +3. There we go, +3. Okay, that's better. So how do we find the answer? So matrix A inverse is going to equal 1 over D. That's the same D we found in the other problem in Cramer's rule, the discriminant. So 1 over D times what we call the adjunct matrix A. Okay, so that's the tricky part, is getting that. So first we need the A transpose matrix. So what is the A transpose matrix? Well, we're going to take this matrix here, A, we're going to transpose it. So that means the first row becomes the first column, so 1, 1, 1. Second row becomes the second column, 2, -1, 3. And the last one is the last one. So that's the transpose. So now the next process, which is similar to the 3x3 determinants, for every single value, for every single entry on this 3x3 matrix, we're going to take that number, I'll do the first one, 1, times, again we do this whole cross out business, times the determinant here. But the end result is going to go positive, negative, positive, which is actually not correct. It's keep, change, keep. That's the sign. And then negative, positive, negative, positive, negative, positive. Again, it's better known as keep, change, keep, change, keep, change, keep, change, keep. And that's the signs. So let's take a look at the adjunct matrix, which is the result of doing all that business, the adjunct of A. So the first entry will be keep. And what are we keeping? 1 times 0 times 0, which gives us a 0. Next, 2 times 1 times 0, 0 times 1, which is 0, change it, but it's still 0. This entry here would be a 1 times 1 times 3 minus 1 times, this is getting messy, so 3 minus a minus 1, which is a 4, and we're going to keep the sign of that. So hopefully that didn't get too messy here and you follow. For this entry, this will be the last one, and then I'll dot 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 it. It's going to be 1 times, now if I cross out, then I have a 2 times 0, and a minus a 3 times a 1. So that's going to be 1 times a negative 3, but I have to change the sign to positive 3, and then that process will continue on and on and on. So the final adjunct matrix is going to look like this. And switch to black. Oops. There it goes, adjunct matrix. So the discriminant, which we already found to be 1 over 4, because the discriminant D is 4, times the adjunct matrix, which is 0, 0, 4, 3, negative 1, negative 1, 1, 1, negative 3. That comes out to be the following matrix, the inverse matrix, which is 0, 0, 1, 3/4, negative 1/4, negative 1/4, 1/4, 1/4, negative 3/4. That's simply multiplying the 1/4 to all the elements in the matrix. So, easy as that, right? So, matrix X, sorry, let me scroll down here a bit. So, matrix X is going to equal the inverse of A like here times the, so what I call, I don't know what I call it, 4, 13, positive 3. I'm glad I caught that in the beginning. And matrix X is the thing we're looking for. That is the final answer. Do you remember this matrix multiplication? It's actually not critical. I don't know that this method is the one we will employ, but it's still good to know it. So we take this column and we multiply it to these terms, and that result will give us 4 times 0, 13 times 0, plus 3 times 1. So 4 times 0 plus 13 times 0 plus 3 times 1, which gives us a 3. Okay, next, we pick up and multiply to that. So we pick up this and multiply it. 3/4 times 4 is 3. 13, so minus a 13 times a 1/4 minus a 3/4. So I'm doing that now, and that comes out to be a negative 1. Lastly, let's see, pick up, lay it down and multiply and add corresponding, and that's going to come out to be 2. And that's our answer. So matrix X, which is matrix of unknowns A, B, and C, equals 3, negative 1, and 2. Again, the same solution we found. We will finish this video with a big old row echelon of sample 3. Actually, I lied. Let's do this one together, and then we'll finish with a nasty one, which is kind of fun. Anyway, let's do it. So we're going to do row echelon. This is the one that I'm holding you responsible for knowing, so let's see if we can't do this. So first off, we have 1, 2, 0 for the C, and 1. That's representative of that first line. The second one would be 0, -1, 2, -1, and finally 4, 0, -1, -21. So let's see if you can remember how this works. Here's a 1. It's already a 1, so that's desirable. We have to make this 0, and it already is, so I'm pretty happy about that. So I have to make this, I'm going to affect this row because I have to make this a 0. So I'm going to multiply my top row by -4, add it to the third row, 0. By -4, add it, -8. Times -4, add it, times -4, add it. Okay, done. Next, I want this to be 0, 1, -2, +1, so that this becomes a 1. Alright, let's do this now. We need to make this a 0. So I'm going to multiply this by a -2 and times it to the first. This times -2 to that. This times a -2 to the 2. This times a -2, which is a 4, to that is a 4. That becomes a -1. Okay, so what do I have to do here? I have to multiply this row, if you can see my cursor, this by 8 added to the third, by 8 added to the third, by 8 added to the third, by 8 added to the third. Okie dokie. So we have now, I want this to be 0, 0, 1. I can get that by dividing by -17. And what can I do? Some manipulation here. So 0, 1. So if I multiply by a -2 and add it, by a -2 and add it. Okay, I'm looking at here, and what do I need to do to this? So by a -4 add it, by a -4 add it, by a -4 add it, by a -4 add it. And what am I missing? Sorry, this should be a 1. Okay, so that then tells us that A is -5, B is 3, and C is 1. The same result we found. The one we're going to finish with now is going to be example 2, row echelon. Let's see if we can't grind that one out. So here we go. The example number 2 from the previous video led us to the system of equations, which I have translated into this special row echelon form. And we're going to begin. So this is a 1, 1, 0, 0, 3. I would encourage you to try it on your own before watching this. Then these need to all be zeros. I'm going to try to do this in one step. This is a 0. Okay, so I'm multiplying this by -6 and then adding it to this row. Actually multiplying it by +6, adding it to that row. So then this becomes a 3, this becomes a 1, 0, 0. For the next one, it's by -12 add, so 0, -12, -1, 1, -7. And for the last one, it's by +8 add, so it's going to be 0, 12, -2, 1, 20. Okay, I'm going to take this, I need this to be a 1, so 0, 1, 1/3, 0, and 0. Multiplied everything, yes, multiplied by a 1/3. And this needs to be a 0, so what do I need to do? I need to multiply by negative, add, so I get 1, 0, negative 1/3, 0, 3, 0, 0, 3, 1, negative 7, 0, 0, negative 6, 1, 20. Okay, so moving along, I'm going to start just writing down some results of this. So I just turned this 3 into a 1, and that's all I did in this step. Next, I made my manipulations in order to get this echelon form, and then I'm going to write the next one now. You might want to press pause. Here we simplified for 1, and then second just divided by 3. And the last step here, we got rid of all these values, turning them into zeros using the method described in the video, and we have found our solution. A is 2, B is 1, C is -3, and D is 2, which would finalize the decomposition, which is the big picture here. The thing we really want to do is be able to decompose larger fractions.